Yesterday we talked about compound events and the amounts of outcomes that you could find inside every compound event. Today we're going to talk about the theoretical probability of compound events. There is one formula you're going to need to write down and then refer back to it as we go through this lesson. I'm sure you recognize this since it's the same formula we use to find the theoretical probability of normal events. But this time it's going to become a little bit trickier because we need to be able to figure out the number of favorable outcomes in every compound event. We're going to go back to our example of the meal. In our original example, we had a situation where you were choosing a main dish of either chicken or beef, and then a side, which could be grapes, peas, or beans. Looking back to our last lesson, we also know that the total amount of outcomes is 6 because there's two outcomes in this sub-event and there's 3 outcomes in this sub-event. 2 times 3 is 6, or as you could see, chicken and grapes, chicken and peas, blah blah blah. What if now we have a question that asks us what is the theoretical probability of choosing a meal with grapes? Just like we've done in the past, our first step is always going to be to write the formula. We know that the probability of this event is equal to the number of favorable outcomes over the number of total outcomes. Using yesterday's lesson, we've already established that the total amount of outcomes is 6, so that number goes on the bottom. From the context of the question, we see that a favorable outcome is defined as any outcome that has grapes. And we see that we have 1 outcome that has grapes, 2 outcomes that have grapes. That means there's 2 favorable outcomes, so we write the number 2. We can then reduce that, and it becomes 1 over 3, or 33%. So there's a 33% chance that your meal will have grapes. We're now going to go back to our last example where we flip a coin 3 times. As we remember, we have a total of 8 outcomes. As we remember, each flip has a possible 2 outcomes. So if we multiply the outcomes of each sub-event, we get the total amount of outcomes. As you can see here, there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. What happens if our question now asks us, what is the theoretical probability of flipping a coin 3 times and only flipping heads once? So we remember our formula states that the theoretical probability is the amount of favorable outcomes over the number of total outcomes. We've already established, like we did in the lesson before, that the total amount of outcomes is 8, so that's the number that goes on the bottom. We now need to figure out how many favorable outcomes there are for flipping a heads only once. This outcome doesn't fit because there's 3 heads, neither does this, neither does this. There is 1 outcome here that has 1 heads, here's another one, and here's another one. Here are all the possible combinations of flipping a coin 3 times and only getting heads once. That means there's 3 favorable outcomes, so we put 3 over 8. If we reduce that to a percentage, we get 0.375 or 37.5%. So there's a 37.5% chance that if you flip a coin 3 times, you'll get heads only once. So the main goals in this assignment, you're going to have to refer back to yesterday's lesson in order to find the total amount of outcomes of a compound event. You're also going to have to identify the possible favorable outcomes. It might be a little bit tricky, so you really need to be thinking about it when you're doing your work. Good luck.